Okay, so we got this cost volume profit analysis thing that we're going to take a look at. So it's called cost volume profit analysis, CVP. And it has its roots in this thing called break-even analysis. Okay, so we might as well learn the break-even first, and then we'll jump to that cost volume profit. So there's two types of costs involved. There are variable cost and fixed cost. Okay, so with variable costs, as you increase volume, the total variable cost becomes more. So if we were to graph it, probably be something like this. Oh, undo that. Why don't we insert a shape here? Okay, so if you were looking at something like this, the fixed cost would remain constant throughout any volume increase. But variable costs would increase as we increase volume. So if you think of this x-axis here as volume, and as units increasing, as we produce or sell more units.
More variables there are.
Yeah, and then the left axis being the total dollars involved. Okay, I haven't put in any numbers on here yet. So no matter how many units you sell, fixed costs are going to stay at the same level. So that's not going to change. That's a straight line. Variable costs will increase. So if we call this line, this yellow line, total cost, right? Well, up into this point, up into where you hit that blue line, that's fixed cost. So even if you don't even sell 1 unit, 0 units, right here, okay, you're still going to have a certain level of fixed cost. That fixed cost is not going to go away whether you sell units or not. But the thing about it is, as you sell more units, fixed cost is not going to change. It's going to remain constant. Okay. So variable costs end up being the piece of total cost that actually increases as more units are sold. Okay, so we'll just throw some numbers in, assuming we move along in $100 increments. Okay. As those units increase, as the volume increases, you could also call this volume. Total cost increases because the variable piece is increasing. Okay. So what we're trying to do with the break-even analysis, and we're going to do it we're going to use two methods, in units and dollars, is we're trying to, first of all, figure out the point where total costs equal total revenue, because that's your break-even point. That's where you don't make any profit, right?
Yeah.
Anything before that break-even point, you're running a loss.
Yeah.
And then anything beyond that break-even point, up in this, if you thought that's your profit, up in this triangle here. Okay. So if you can kind of visualize that, then I think this will make more sense. Right. So let's take break-even in dollars. So if we were to take break-even point in dollars, we have a formula, and the formula is we take fixed cost and we divide it by whatever the price of our product is, so price minus the variable costs per unit. Okay. So quick example, say you have a, let's just say your company sells baseball caps, which cost $5 to make. The caps sell to customers at $25 each. Rent on the store space is $6,000 per month, which includes utilities. Okay. And we'll just make it simple. There are no other fixed costs, but the company is required to pay let's just make this simple, 5% of its revenue in percentage. We'll just call it percentage rent to the mall. Okay. You got a situation now. Yeah, your company is selling these baseball caps. They can make them so they're variable cost. When you get a problem like this, what you have to do is you have to kind of fish out what's variable and what's fixed. So it's a real simple problem. I threw a little bit of a minor complexity into this with this 5% gross percentage rate rent that you pay to the mall. Okay, a lot of times malls do that. It's probably not going to be that straightforward. Sometimes it's 5% on everything after $1,000, or 5% on anything beyond a certain revenue figure. But we'll just do it this way, okay? So what you're doing is, when you think of a problem like this, you want to break it down variable and fixed as far as costs go, and you just start thinking about it. Okay, in the variable category, we have $5 per cap, right? That's the straight, right? If you sell one cap, you got $5 in variable costs. If you sell two caps, it goes up to $10, right? If you sell three caps, you got $15 in variable costs. So that's why it's variable. Go back to our graph here, right? Take these numbers out. For each cap that you sell, you're getting a incremental cost, an additional $5. Okay. Now fixed cost ends up being the $6,000 per month. Okay, and there could be several fixed costs, but we'll just take that one thing. So we got $6,000 per month rent. Right. Now, the thing about it is, this 5% here is also a variable cost, because for every cap that you sell, right, every $25 that you have in revenue, you're going to pay 5% of that back to the mall. Okay, so if you don't sell any caps, you're not going to pay any percentage rent. Okay, if you sell two caps, you're going to pay 5% on $50. Okay, if you sell three caps, you're going to pay 5% on $75. Okay, so it just keeps going. So we can put that in a kind of put it in formula terms. It's going to be whatever number caps you sell, right, times 5% times $25 multiplied by the number of caps. So what our thing here is, our goal is to get this into our formula. Our formula for break even in dollars is we take the fixed cost. So maybe we can do it out here. We'll take our fixed cost divided by, and we'll abbreviate, price minus variable costs per unit. And that will give us our break even in dollars. So let's see. I'll take my fixed cost of 6,000, and I'm going to divide it by my price of 25 minus my variable cost of 5 per cap plus 5 cents times $25. Does that look like it works? What's missing?
So.
Is it as simple as saying 5% times 25?
About the number of caps.
That's what we're solving for, right?
Oh.
Right? So we may need to put that number of caps, and I have that labeled wrong too. We're trying to do break even in units, right? We're calling it dollars, but we're doing break even in units. So we're looking for the number of units, right?
Yeah.
We're not looking for the dollars, so we can call this break even in units. Okay. Why don't we test it? We'll go. I'm missing a parenthesis. It's not letting you move around. Okay, let's see. 6,000, 25 minus 5 plus 5% of 25. One more parenthesis. Okay. So it says we got to sell 320 units to break even. So we can test that, right? If you think about your income statement. Okay, you got revenue. So in our case, our revenue would be 320 caps times $25 per cap. So let's see what we get. We get 320 times 25. So we make 8,000 in revenue. Why don't we test it, okay? And then we'll do our variable costs. So we're going to have costs per cap, and that's going to be 320 times $5. Okay? So we'll put the 320 times 5 here. Oops. Okay. Pull that guy out so we can. And then we can take away, well, for now. And then what we got to do is we got to take the percentage rent, right?
Mm-hmm.
We'll just abbreviate. Percentage rent is going to be 320 caps times $25 times 5%. So let's see what that is. We'll go equals 320 times 0.05, we'll do it like that, times 25. 400. Yeah, we did not hit it correctly, right? What did we do wrong? $320. Oh, I think we're on the right track. I'm sorry. Okay, so if we added these two together, this plus that, that's 2,000. Watch this. We got it right. So this is our total variable cost. Okay. So I want to show you something here. The difference between revenue and variable cost will be called the contribution margin. So if I take 8,000 minus 2,000, I get a $6,000 contribution margin. Then what we're going to do is we're going to subtract the fixed cost. Remember, fixed cost was $6,000. So when we subtract $6,000, you get 0. Right? When I subtract it, so my net income is 0. That guy minus that. So we took the facts, applied it to this formula, break even in units. Okay. We came up with 320 units to break even. Then we plugged it into our income statement to test it, kind of like to prove whether we got it right or not. And when we take 320 caps times the revenue, we get 8,000 in revenue. Then when we take that same number of caps, 320, and multiply it by the cost per cap of $5 and the percentage rent, which is 5%. For every cap, it's 5% of $25. That's why this works, right? 5% of 25. You get 400. So that's a total of 2,000 in variable costs. And we get a contribution margin, which is revenue minus variable cost of 6,000. Okay. And then if you subtract the fixed cost, you get nothing. Okay, so that's the break-even formula. Now we could tweak this a little and get this cost, volume, profit thing going. Say we got the same situation. Okay. But your company aims to make 4,000 per month in profit. Okay, so I took the same scenario from up here, but I'm expanding it to include a profit target. Okay, so now we got a profit target involved. We're going to start off doing the same thing. So I can borrow this stuff, and then we'll just take the numbers out for now. Okay, so we're going to start off doing the same thing, but the formula is going to be different. Because we want to end up with 4,000 down here in profit, right? So if I were to take my original formula, which we call break even in units, and I want to get to a target profit, right? So basically they usually end up calling it CVP, right? Cost, volume, profit analysis. We'll do it in units, but that when you do that, what you do is the way you modify this formula is you basically, in the numerator here, to the fixed costs, you add your target profit. Okay? So real simple tweak to the formula, right? All we're going to do now is, since we want to get 4,000 in target profit, okay, and we might want to add our variable here too, right, in our list of things, right? We got to know what our target profit is, and that's going to be 4,000 per month. Okay. If we do that, now we can take our formula, and I have it listed down here, and then feed it back up here. We'll say I want to call it the CVP in units. Okay? You could modify that to show that you're going to add your target profit to the numerator. Okay? So if we steal this stuff, oops, and we're kind of doing it longhand just to. Why don't we just take that like that, put it over there. Okay. We'll take 6,000 plus 4,000, right? And we're going to divide by the same thing, right? So when we do that, we should end up with and I already have the math sitting in my Excel sheet, so I'll come over here and just add 4,000 to the numerator. Now we have to do 533 units. Okay. So what I'm going to do is I'm going to come back through here and I'm going to test it. Okay, so now my revenue is going to be 533 caps times $25. So let's see how this works. I'll just change the math. 533. Okay. My variable costs for each cap, total variable costs, will now go up to 533 caps times $5. Right? And then my percentage rent will be basically the total revenue, which is 533 caps times $25 times 5%. So let's see if that's what's happening here. W68. Yeah. Okay. Now, we got a bit of a rounding thing going on, so that's why we're not hitting 4,000 exactly. You see what I mean?
Yeah.
We got Excel rounding for us. So it's close though. You could say roughly 4,000, right? 399, 3,993.75. So, what? $5.25 shy. Basically because of this here, right? Let's try doing that out longhand. It's going to be the same thing anyway though. Let's go. 533 times 25 times 5%. Oops. Need to put an equal sign before you put any formula in. Yeah. So I would say you need to sell
534 if you want to hit the 4,000.
Yeah. And you could test that out too. You could put the 534 in. Why don't we do that? Because that takes you up to a we're going to plug in 534 now. yeah, you're already over the 4,000 once you get to 534.
Yeah, it was like 533 and like 1/3 or whatever they had for it.
Yeah, because the rounding is over here,
Mm-hmm.
right? So if we show all the units here, let's see, all the spaces, all the decimal places. See, 533 and a third. So one thing you could do is you could just use that number. If we were to just use that number, whatever that is, and we reference it, we could say reference that. And over here we could say, in our formula, right, instead of just putting a straight 533 in, we could reference that. But you're not gonna, I don't think you're gonna sell 1/3 of a cap,
Yeah.
0.33, but see, then it'll come out exactly. Yeah. So that's the way we do that. Two things to remember here. Break even, right, in units, and then our cost volume CVP in units. Yeah? Okay. So if you do have a profit, it's going to be showing up in this triangle. I think our book gives us a good graph too. Let's see what our book says. Our book breaks it down for us. So it starts with variable cost. Then it talks about fixed cost. So you get to see it in pieces. Right, and in this example they have a flat $12,000 fixed cost. And then they talk about the break even, and they have a graph of that. Where did our break even graph go? And they have a good problem that they walk you through. Here, that's exhibit 20-7. That's a pretty good comprehensive graph of a break-even point. Not the one that we did, but right. So they got their total revenue, this blue line.
Mm-hmm.
So as they increase the units, total revenue goes up, and then they got their total costs, which is the green line. So you notice total costs. The total cost line actually starts at the fixed cost total, right?
Yeah.
And then as you add a unit, total cost is going up because of the variable aspect of total cost, right?
Mm-hmm.
Okay, so you know technically you could graph the variable cost separately, but it makes more sense when you're going after this break even to show a total cost line, because break even is where total cost, which is the green line, intersects with total revenue, which is the blue line. Okay. And then the graph is nice because it shows you anything before you hit that break even point, you're running a loss, and that's what's in orange over here, this triangle. That would be your loss. Anything beyond that break even point, that's going to be income. That's what's in the green here.